Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 18 of the February daily LeetCode challenge, and we again have a medium question in front of us. Remember, from the last 2 days we are getting questions on the topic of backtracking, and today also we are getting a similar question, which is again based on backtracking. I will say this question is totally similar to what we have seen yesterday. That is a day 17th video. So if you have not tried that out, please do go and try that out, because you will see a lot of resemblance between yesterday's question and today's question. Okay, so let us quickly begin without taking much of your time. It is 2375. Construct smallest number from DI string. Okay, so what we're given basically, see, I am assuming that you would have already gone through the description of this question before coming to this video. I will always in my videos I give the question like in the description and the answer in the solution, that is in the comment section. Okay, so you always have an opportunity to go and see the question before continuing in the video. Okay, so I'm assuming that you would have done the same, and you would have gone through the question again previously. So see, the only thing that I want to highlight is that the length is going to be up to 8, and the input is only going to consist of i's and d's. Okay, what are i's and d's? I assuming you have already gone through the question. I'm just revising in case you have not understood it fully. See, if I is present, what it means, if I is present, that means for that particular index, let us say I is present in index I, that means the I plus 1 value has to be greater than the i's value. Okay, in your answer. Okay, now in the pattern of I, let us say it is d, that means in your answer the I plus 1 value has to be less than the ith value. Okay, that's what it means. Okay, that is something that I want to tell you. Okay, other than that, if you see your input value of length n, your output value of length n plus 1, both of them are going to be string. Input and output both are going to be string. Other than that, you have to return the lexicographically smallest answer. Okay, these are some of the highlights that I just wanted to brush up once before going to the solution. In case you have not understood this part, you can get it. Okay, and one more thing is, you have to use see, we are only allowed to use numbers 1 to 9. Okay, no zero allowed. That is the only thing. No zero allowed. Only 1 to 9 you are allowed, and everything should come at most once. Okay, that is, you cannot repeat any number between 1 to 9. Once you have used it, you should not repeat it. Okay, that is all. So I've touched all the important aspects of this question. I'm not reading it fully. I'm expecting you to do that, because already the links are there in the description. Please go out, read once, then come back to the video. Okay, now how to solve this question? See, I will say you two approaches. Approach one will be, I will say, the brute force way. Brute force way will be, try to see, because the input is okay, the constraints are very low. Okay, what you can do is try to build all possible answers, among them then do a sorting and get this smallest answer lexicographically. Okay, I'm assuming you know what is lexicography. Okay, let us quickly go for example once. See, let us, you have two numbers. Okay, 1 3 5 6. Okay, and the other number is 1 2 5 and 6. Okay, now can you quickly tell me among them which is going to be the lexicography smaller? Now see, you may be able to guess that okay, this is the smaller number, so it will be lexicography smaller also, but remember that will not be the case always. See here, what happens, no, lexicography smaller means at this first point of difference, what is the smaller number? Okay, let us compare. This is the first one. Okay, here also it is 1, so both are same. Let's go to the next one. Here it is 3, here it is 2. So here is the first point of difference. At the first point of difference, which is smaller? Okay, 2 is smaller here, so among 2 and 3, 2 is smaller. So this whole thing will be called lexicography smaller than this thing. Okay, so what it, to conclude what we have seen, at the first point of difference, whichever number is smaller, that will be declared as the lexically smaller string. Okay, as simple as that. So this was the example for that. Remember, we are not even comparing 5 and 6. Okay, because at the first point of difference itself, it is decided which string is going to be lexically smaller. Okay, that was all right. Now we have understood what is this also, and we have touched all the important aspects of this question. So let us quickly dive now. Okay, so the first approach that I mentioned already is that you can get all your possible answers, and then among them, see, all the possible answer means all the possible answers which are satisfying this condition. Among them, whichever is the smallest one lexicographical, that you can take as the answer. Okay, that is the first approach. That will, I will say, is not the optimal way of doing it. Okay, because in the recursion, what you can do is you can always try to get the answer directly without going through all such possibilities. Okay, so the idea is, when you reach a string of length n plus 1 satisfying all these constraints, you should ensure that you are reaching the answer directly. Okay, without wasting much of your time. So we will do that in my solution. The first answer, that is the first string that is we are reaching of length n plus 1, that is going to be our answer. Okay, let me quickly show you how it works. I am capturing the length and I am declaring the numbers. Okay, remember here it is only 1 to 9, there is no 0 involved. This is my answer. Initially it is empty, and at last this is going to be the answer that we are going to return. Okay, now see here, we are declaring a recursive function. Now quickly tell me, what is a recursive function? Recursive function is something that is going to call itself. Okay, the function is going to call itself. If you see in this code, we are again calling the function itself. Okay, the function is calling itself. That is why it's called a recursive function. Okay, in order to trace it, you have to basically do a stack tracing. Okay, each stack has different variables. You have to go to each stack and you have to understand how this function works. So each basically function call will have 3 such parameters. Okay, as simple as that. So you have to basically trace it in a stack way, okay, because there are different stacks created when you are implementing this. No, the compiler, when it executes this, it creates different stacks for each of these functions also, okay. That's why it is implemented. That's why the common name comes Stack Overflow, okay. There is a website also for this name, Stack Overflow. It's a very common website. The name is coming from this only, right? Now what we are doing, see, the idea here is you will be given a string here, okay. Then you are going to given index. See, this index means this is the index that you have to refer in a pattern, okay. In a pattern, let's say the index is 0. That means you have to return your index of 0 in order to determine the current value to be chosen, okay. As simple as that, okay. And the use number tells us which all numbers are used, okay. As simple as that. So as I mentioned, see, the input is going to be n, and the final output is going to be n plus 1, okay. So the idea here is, let me quickly tell you one thing, okay. See, here triple D sub n, that means your last three digit of your output is going to depend on, that is, it's going to be decided on based on this, okay. But remember, the first digit of your answer is not decided based on this, okay. You will have to take it randomly, or whichever heuristically possible way you have to take it. But again, after that, the first number will be chosen based on your experience, or based on your optimization. But the last three digits will be determined, okay. Last three digits which are coming will be determined based on your pattern, okay. That is what I'm trying to tell you. So the idea here is the first digit is always something that you have to choose in such a way that you are getting the best possible answer, okay. It's up to you how you're choosing that, okay. But after that, once you've chosen the first digit, the other three digits are going to follow these conditions, okay. As simple as that, okay. There are some conditions to be followed after that. So for that reason, this is how I'm doing it. See, what I'm doing is I'm going through all my numbers starting from 1. I'm going till 9, excluding zeros, okay. But then what I'm doing is I'm going to call this function, okay. This is a recursive call I'm doing, okay. Now I'm passing I, that is the string buildings have starting from here. I'm passing I. This 0 tells us that you will have to, for the next index, to add to the next character that we're going to add to the string. For that we'll have to refer index of 0, that is index 0 of pattern. That is what this 0 means, okay. As simple as that. And we are creating a set. This set will tell us which all digits we have already added, okay. In this I am passing a iterable containing I, okay. In this I'm passing a list containing I, which you can call it as a iterable containing I, because in the constructor for a set you have to pass a iterable. Whatever elements are there in the iterable, that will be added to the set, okay. So in this case I'm passing a list with I. So the I is taken from the list and added to the set, okay. Remember, we are not passing list as a input to the set. That's not happening, okay. If you print this set, you will get only I in the as a element of the set, okay. As simple as that. Because when you're passing that to a constructor, all the elements will be taken from the iterable and they will be added to the set, okay. Now if this function returns true, we will return directly the answer, okay. That is whichever first answer, okay. When you see this part, will understand is that whichever the first answer we are getting of length n plus 1, that is going to be your final answer, okay. Now see here quickly what we are doing. Yep, we are declaring these things as a non-local. Okay, why we are doing that? I explained multiple times in my video. If you have not answered this part, please do Google what's non-local and why it is needed. The idea here is whichever values are you are referring outside the function, that has to be declared in a non-local way. Okay, now we are creating two basic stop conditions for our recursion, okay. See, if length of s, that is the string that we are trying to build, if it is equal to n plus 1, okay, because if we reach n plus 1, that means either we have reached the answer or we have to stop, okay. And the answer is equal to empty, okay. Since we are starting with empty answer and the answer equal to empty, that means we have reached the right answer. We have to change our answer now, okay. Remember, because of the way we are doing the things, because if you see here also we are starting from 1 to 9, here we also we are starting from 1 to 9, that is the first answer that we are going to get, satisfying all these conditions, okay. Just a second. Satisfying all these conditions, okay, that is going to be our final answer, okay. That is the reason why we are doing this. If the string is empty, only then capture, others don't capture, okay. So you will capture the answer and you will return true. So return true means that you have reached the answer. You will stop. You will start pruning away. That is, whichever tree is open, whichever branches are open for a recursion, recursive branches are open. You have to stop that and you have to come back now. Okay, you have to start the backtracking process. Okay, let's say if this condition is not true, the other condition is that if the length of s equal to n plus 1, in that case also you have to return false, because the previous condition was not. That is, the answer is not equal to empty. Maybe that is why this condition was not true. So in this case, if you have this condition is true, you'll have to return false. False means that you have not changed the answer. You have to keep continuing your trees. Okay, now see here for I numbers, okay, if I is not used, remember this will start from 1 to 9. If I is not used, in that case there are two things now, okay. If this condition is true or this condition is true, okay, if either of them are true, you have to continue. What are these conditions? See, if the pattern index is equal to I, that means the last entered value in s should be less than the current value, okay. Otherwise, let us say if the pattern index is equal to d, that means the last entered value in your string should be greater than the current I, okay. Now in each of these cases, what you have to do, add the I in your use number set, then start a recursive function call, okay. Here what we are passing, here we are adding I to our s, okay. That is, we have added a new character to our string, okay. I'm adding I to s, then I'm doing index plus 1, because now we are going to the next index, and you're using passing the set, use number set. Okay, we are doing this recursive function call, that is we are going to the future now. Okay, if this future returns true, that is if we are getting true, that means, see, this is, you can think of it like a function call which is taking you to the future. If this future returns true, that means if you are taking this input and you are getting true as the return value, that means you have taken the right time. Okay, you have taken the right value. You can stop all other, see what is happening. If this is true, then we're returning. That returning means we will not execute the statement, we will not go to the next iteration, all that. Okay, returning to means we are directly returning from this function. We are pausing any further explorations. Okay, we are pausing any further iterations. Okay, as simple as that. So once we reach to, you have to pause everything, you have to return back. Now you have to start backtracking now. Okay, now let us say if this doesn't return to, what will happen in that case? You will have to go, that is, this particular value is not the ideal value for this. Okay, so what we'll do is we will remove this value and then we'll go to the next iteration of I and try with the next I. Okay, if this next I returns satisfy all these conditions, then we will again add it, we will again do a function call. Okay, and then we will again check. If it's again not true, we'll again remove it and then go to the next. Okay, this will keep continuing. Okay, at last we are returning false, because remember, let us say you are in Java code, always happens, in Java you'll have to always return something. Okay, though this code is not reachable, in our case this is not reachable, but again in Java, let us say you are, try to replicate this code, then you have to again return something, right, at last. So for that reason, what we are doing is at last we are returning false, but based on my experience, this should be non-reachable code. Okay, same thing here. If you see here, we are just doing a function calls with all possible i's. Okay, i's, see, this I means that it is going to a starting character. Okay, we are trying to keep all the i's I have starting character from 1 to 9, but we're starting with 1. Okay, remember that from 1 we are going till 9. Okay, we're trying to give all of them as starting character, but in between, if any of them is returning true, then we're returning that as the answer. Okay, at this step the answer would have been captured. Okay, and then when we are, this function is returning true, we are returning that answer. Okay, again this code will be a non-reachable code, that should not be reachable because of the type of input that we're getting, because of the type of code that we implemented should not be reachable. But again, just for your namesake, you can add it. Okay, this should not be reachable according to me. Similarly, this false statement should not be reachable. Okay, yep, this was the whole breakthrough of this code. You can go through it. I've also captured some outputs that will help you understand why in the first attempt itself we are reaching the answer. Okay, remember the other way around, what you can do is you can generate all possible cases, then compare them using a sorting way, and then return the smallest lexicographical string that you can do. But in our code, we are doing in a very optimized way. We are not doing all those cases. The first thing that we are going to get of length n plus 1, that is going to be an answer in this case, because of the way that we have implemented it. Okay, we are against always starting from 1. Okay, and here if you see, we are again starting from 1. So whichever way, see, if you see the way that things are happening, see, after 4 2 is coming, after 4 3 is not coming directly. Okay, as simple as that. So because this way we are always ensuring that we get the lexicographical smallest string. So often that was all for this video. I have added multiple print statements here. You will get a lot of output here if you do. So maybe I will give this code in the comments. Take it, try to run it. You will get all the recursion tree, basically how the things are happening, and maybe you can go through it. Okay. Example one, I will say do not go at it at the starting because it's a very long one. Go with example number 2 and maybe example number 3. Example number 3, I guess I have added myself. It was not there already, but yeah, it is a very good one. You can go through it. Okay, in my Hindi video, I basically explain the whole thing here in detail. I'm not doing that again because yeah, it will take a lot of time otherwise. So English videos I'm trying to give very short. A very detailed explanation is usually I'm giving in the Hindi videos. Okay. So often that was all for this particular question. If you have anything to ask, if you have anything to say, if you have if you feel this code is helping me in certain way to learn something new, the quality of this content, if you are liking it, please do subscribe to the channel. This really takes a lot of effort to make this kind of videos and to reach out to people. If you like, maybe this video will go to multiple more people who can get something more to learn. Okay, that was all, and it was my 119 video. I hope there are a lot more to come. See you tomorrow. Thanks a lot.